Hopefully I'll do this all right. So exponent rules with fractions. So I just want to remind you of a couple of things. A couple of fractional things. If you have fractions and you're trying to multiply fractions, so let's say you have 1/3 times 4/5. You're multiplying fractions. You multiply the numerators, the 1 times the 4, and multiply the denominators, 3 times 5. So the end result on that is 4/15. But if you take those same fractions and you add them, you need a common denominator. So if I were going to do this, I would really need a common denominator. The common denominator in those two fractions is 15. So I would really need to multiply this by 5/5. That's 1, so I can multiply by 1. And I don't need to multiply this one by 3/3. Because then, if I do that, what I end up with is, again, using multiplication with fractions, is you end up with 5/15, multiplying the tops and then the bottoms, plus 12/15. Now I can add those because I have the same denominator. So if I add those, I end up with 17/15, and that's my answer. So remember that that's what we're going to be using because we're going to be doing exponent rules with fractional exponents. So I'm going to write the rules down, and I just want you to finish them. So I'm just going to write one side of it down, and then you have to see if you can finish them. Pause the video and see if you can finish them. So if we have a to the m times, a to the m times a to the n, you're going to finish that one. If we have a to the m divided by a to the n, I'd like you to finish that one. If we have a to the m and then parentheses to the n, I'd like you to finish that one. And then if we have b to the p, a to the m, and all that raised to the n, we need to know what that is. If we have a to the 0, I need to know what that one is. I need to know what a to the negative m is. And I need to know what 1/a to the negative m is. So we're going to still use all of these, but with fractions. A couple of new ones. If you have the nth root of a, if you don't know what that is, we can talk about what that one is. So pause the video, go ahead and fill these out. Okay, if you pause the video and you're back with me, this first one, hopefully you have a to the m plus n. This one you have a to the m minus n. This one you have a to the m times n. This one you have b, p to the n, a to the m times n, because you have to kind of distribute that n through. This one is 1. This is 1/a to the m. Remember, if it's in the other part of the fraction, if it's negative, we move it to the other part of the fraction. So then this one is a to the m. This last one is a to the 1/n. So that's how we're going to get fractions, as we end up with radicals. So for example, the square root of 4 is also 4 to the 1/2 power, which we all know is 2. So those are some different things with exponents. So now let's look at some examples. If we're going to express this one in radical form, that's using this last rule that I just wrote. Expressing this in radical form, we would write this as the 4th root of x. So that's the 4th root of x. Just to kind of give you some ideas here. The 3rd root of 8 is actually equal to 2 because 2 times 2 times 2, or 2 to the third equal to 8. So that's what that's using, if you're wondering. But for this first problem, we were just trying to rewrite that in radical form. If we write this one in radical form, we could write this a couple different ways. We could write it x, we could write the 4th root of x cubed, or we could write the 4th root of x cubed that way. Either one of those is actually appropriate. So we can write it both ways there. All right, take something like this. Evaluate the left-hand side of a in the simplest form. Remember, if we think about this, this is x to the first. So basically they're saying, okay, take the left side and simplify it and tell me what a is. So we got x to the 1/3 times x to the first. If we go back up to our rules, that's x to the 1/3 plus 1. Well, remember now with fractions, we can't just add those together. So 1/3 plus 3/3, which is x to the 4/3. And if that's supposed to be equal to this x to the a, then a must be 4/3. And that's the answer. And that's in simplest form because that's reduced. Okay, let's take this next one. This one is x squared, x to the second times 2/3. Remember that if it's 2, that's like dividing by 1. So if we multiply those like we would multiply things, this would be 4/3. So a is equal to 4/3 in this one. That just happened just the way I picked it. Those are pretty easy problems. It's a little bit more difficult. If we're trying to select the expression that equals it, this isn't so bad. I mean, it looks terrible, right? I mean, you might think this looks awful. But one thing we could do is we could say, okay, well, let's do this in steps. Well, isn't this 1 over a to the 13th? Because 6 plus 7, and all that raised to the 3/52. You go, oh my God, that still looks terrible. Well, it's not too terrible. If I take this and go down here, I say, okay, well, this is 1 over a 13. Let me just do this. If I write this as a to the negative 13, all that raised to the 3/52. If I want, just to not deal with that fraction for temporary, I can move that, make that negative, be up to the top. And then this is a, and 3 times 13 is negative 39 over 52. And now my question is, what does that equal? Because that's, that 3 over that 39/52. And we can reduce that. We can probably make something go in there. But what it turns out to be is that is a to the negative 3/4. And so that's 1 over a to the 3/4, which is 1 over let's see, we'll do 4a to the 3rd because of that fraction. So there's our answer right there. So that one's a little bit more tricky. We're dealing with those fractions, so you might need a calculator to deal with those fractions. That's okay. I mean, I typed in 39 over 52 and got 3/4. I got 0.75, and I knew that that was 3/4, so then I just converted it. So use a calculator on that if you want to, on the fraction, but know the rules. Take one like this. This one's pretty easy. If you think about what happens is that negative exponent, we could take that negative exponent, and remember that negative exponent could just be brought into the top with a positive exponent. And then what we could do with that fifth, we could think, oh, that's just that root thing. That's that fifth root thing, 2x squared plus 2, which is right there. So when you have that multiple choice, that's how you deal with that one. Simplify the following one using positive exponents. Here's where I might have you use a calculator on this, on the number part of it. So on this one, we have 16 to the negative 5 halves minus, or sorry, not minus, x. And if we take negative 2 times negative 5 halves, so we got negative 2, I'll write it out, times negative 5 halves. We got y, we got negative 16 times negative 5 halves, and we're just going to multiply these out. This one, use Desmos calculator. Okay, so use a Desmos calculator for that one. If I did that, what I did is I did 16 to the negative 5 halves, 16 to the 5 halves. I got 1024, and since there's a negative, I'm going to put that in the bottom part of the fraction in the denominator. If I take the next one, this would be x. Since I have two negatives, I got negative 2 times negative 5. That's 10 over 2. I can reduce that. And y, if I take 16 times negative, or 5 times 16, I get 80 divided by 2. Now I can reduce those, so it's asking me to do simplest form. So I'm going to write it as 1024, x to the 5th, y to the 40th. And those are positive exponents. So pause that one. But remember, I just use the Desmos calculator on the number parts. Use the properties here to figure out what we have. Well, it's really nice if we have them all in the same kind of thing. So I'd write this as x on the top. This is 5/3 because I multiply those exponents. Divided by, this is x to the 4th, all raised to the 1/3. Or together, x to the 5/3 divided by x to the 4/3. Well, now we subtract those exponents using that rule. We got x to the 5/3 minus 4/3, which is x to the 1/3. So a is 1/3. Just using rules, just using the rules. So that's why I've had you write them down for the 3rd day in a row. And that's the last example. So hopefully that makes some sense. Hopefully you understand it. Miss Husing's videos are on there too, so use hers if you don't want to listen to my voice. She's a lovely person.